Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine an organism so resilient it easily survives the vacuum of space, temperatures hovering near absolute zero, crushing deep ocean pressures, and blasts of lethal radiation that would instantly kill a human. Meet the tardigrade, also affectionately known as the water bear. For centuries, these microscopic, eight-legged animals have utterly baffled scientists with their extraordinary ability to cheat death. When environmental conditions become hostile and dry, they enter a state of suspended animation called cryptobiosis. During this process, the tardigrade expels almost all the water from its body, curls up into a tiny, shriveled ball called a tongue, and suspends its metabolism entirely. To all outward appearances, the creature is dead. Yet, when rehydrated, even decades later, it simply wakes up, stretches, and walks away. How does a living creature survive losing 99% of its body water? In almost all other organisms, extreme dehydration is fatal. Without water to support them, delicate cellular proteins lose their three-dimensional shapes, clump together into useless masses, and become permanently damaged. At the same time, cellular membranes rupture, destroying the structural integrity of the life form. For years, scientists assumed tardigrades must use a specialized protective sugar called trehalose to shield themselves, similar to resilient desert plants and brine shrimp. However, chemical analyses revealed that tardigrades either lack trehalose entirely or possess it in negligible quantities. The exact mechanism of their survival remained an elusive mystery. The breakthrough eventually arrived not from traditional biology, but from the physics of glass. Researchers discovered that tardigrades possess unique genes coding for what are known as intrinsically disordered proteins, or TDPs. Most biological proteins require a rigid, three-dimensional shape to function properly. TDPs are entirely different. In a hydrated environment, they are flexible, shapeless, and highly dynamic. But as the tardigrade begins to dry out, these bizarre proteins undergo a dramatic molecular transformation, rapidly linking together to form a dense, protective network. This is where glass physics comes in. Instead of organizing into a neat, repeating crystalline structure like ice, the TDPs form an amorphous solid. In physics, this state is known as a glass. Unlike crystals, glasses have a highly disordered atomic arrangement, yet they possess the mechanical rigidity of a solid. In essence, the tardigrade undergoes vitrification, turning its entire cellular interior into biological glass. This intracellular glass acts as a molecular scaffolding. It gently wraps around the tardigrade's delicate enzymes, proteins, and genetic material, locking them securely in place. This prevents the proteins from unfolding, breaking apart, or fusing during dehydration. Think of it as packing fragile ornaments in customized bubble wrap, or preserving ancient insects in fossilized amber. Because this glassy matrix is incredibly stable, it preserves the delicate machinery of life in perfect stasis. Metabolic reactions pause, but the structures needed to restart life remain fully protected and pristine. When environmental conditions improve and liquid water returns, the process beautifully reverses. The glassy matrix dissolves quickly and cleanly back into flexible, individual TDPs. Cell membranes expand, trapped proteins regain their mobility, and the metabolic engine of the tardigrade sparks back to life. It is a flawless transition from a living organism to a glassy statue, and back again. This intersection of glass physics and biology has massive implications for human technology. Today, keeping vaccines and blood samples viable requires a strict, expensive, cold chain of continuous refrigeration. By studying how tardigrades vitrify cells, bioengineers are developing revolutionary ways to dry store life-saving pharmaceuticals at room temperature. This could democratize healthcare in remote regions. Furthermore, understanding vitrification could lead to advanced crop preservation and even pave the way for long-duration space travel, where human cells might one day be stabilized using similar principles. The humble water bear proves that nature often solves complex survival challenges by exploiting the fundamental laws of physics. By turning themselves into glass, tardigrades have conquered the limits of biology. For more incredible facts like this, don't forget to subscribe and turn on notifications.